Good morning all. In today's video, we'll see about the topic direct memory access. I'm Professor Srilata from Sai Vidya Institute of Technology, and I'm handling the subject computer organization. So, direct memory access. What is direct memory access? Here, as the sentence says, it is accessing the memory directly. So in the previous videos, you have seen the interrupt, okay, interrupt concept. So what was happening there is, whenever the data has to be accessed from input-output devices, okay, also called as peripheral devices. So how was the data is transferred? Here, whenever the data buffer is full, okay, so whenever the data in buffer or data out buffer is, when the data is full, okay, in data in buffer, a signal is sent to the processor, an interrupt request signal is sent to the processor, indicating that there is data in the buffer, okay, and the data has to be handled by the processor now. So the data is taken to the processor, okay. So as you had seen in the previous video, there is acknowledgement sent to select the device from where the data has to be taken, okay, all that is there. Now data is first sent to the processor, okay, and then suppose the data has to be put to the memory, okay. From the processor, the data is put to the memory. So always from peripheral devices, the data is taken to the processor and then to the memory. Suppose it is the display of data which is required, and the display has to be taken from the memory, okay. The data has to be taken from the memory, then again data is taken from the memory to the processor, and then from processor to the output device, okay, output device. So this is the procedure which happens. That is, always data has to go through the processor and then only to the memory, okay. So this the intervening of the processor can be avoided by a concept called as direct memory access, where the input output devices or the peripheral devices is communicating the data, transferring the data between the peripheral devices and memory takes place directly without the intervening of the processor. This is called as DMA, direct memory access. Okay, when there is a block of data, large amount of data which has to be transferred to the memory, so in the program the instructions can be written such that the functions can be used such that the DMA process is invoked, okay, and the processor informs the peripheral devices that DMA has to happen, direct memory access has to happen, okay. It also gives the required information. We'll see what are the required information. It also gives the required information to the memory. The required information is passed to the input output device so that data is handled, okay. Now what is the we'll see what type of data or what information is sent by the processor to the input output device for processing this direct memory access, okay. So that is direct memory access, the concept of direct memory access, where the instead of processor being intervening the process of transferring the data from peripheral device to the memory, the processor is not intervening here. Directly the data is transferred from the input output devices to the memory, okay. Now what is the, we'll see the definition. So as per the definition, direct memory access is a process, okay, it's a process of transferring block of data at high speed between the main memory and the external devices or peripheral devices or IO devices, okay, without continuous intervention of the CPU. So as I told, without intervention of the CPU, the information is transferred. It can be from memory to the external device, called as a read operation, okay, or from external device to the memory. So you're writing to the memory. So write operation. Okay. So for this process, that is transfer of data from the peripheral devices or IO devices to the memory, the direct transfer, there is some circuits which is helping out the input output device. So you know, there is something called as interface circuit for the input output device, which has a buffer, which has the address decoder, the data and status register. So all that registers which helps in transferring of data is present. That is, the interface circuit is there between IO devices. So at the port of where the IO device is connected to the system. Okay, that is, there is the processor, there is the motherboard. Okay, in that, suppose this is the motherboard, which is nothing but the system. Okay, so here there are ports. So there, where the input output device is connected. Okay, so to that there is something called as interface circuit. Okay, we have seen it in the previous classes. There is interface circuit. In the interface circuit, there is another controller. It is a hardware part, which is called as the DMA controller. Okay, again, it has some registers which stores some information. We'll see what are the informations. Okay, so just suppose this is a keyboard. Okay, this is the keyboard. Keyboard is connected to a port in the system. Okay, there is memory, there is the processor. Okay, there is the processor. So this is the processor. Fine. There is interface circuit, and which is connected to this port, and in the interface circuit there is something called as DMA controller. So DMA controller is controlling the operation of direct memory transfer between the keyboard and the memory. Okay, without the intervention of the processor. Fine. Now, in the processor, the program is under execution. P1 program is under execution, and P1 needs the direct memory access to take place, because it has to transfer a large amount of data from the suppose hard disk. Okay, from the hard disk or from the network. It wants to take a large amount of data, read large amount of data from the network at once. Okay, so when this is the situation where the program wants to read or put a large amount of data at once. Okay, so in the program, instructions will be written for the direct memory access. Okay, so here the processor will know that the program needs direct memory access. The processor will invoke direct memory access, give permission for direct memory access. Okay, so along with giving the permission, it will give some informations what is required for direct memory access. So what are the informations required? Suppose I am reading large amount of data from the memory to the disk, okay, or to the network cable. So I want the location from where the data has to be read. So start location from where the data has to be read is required. Okay, length of data which I want to read from, which has to be read from the memory, that is required. Okay, and yes, what is the type of operation to be done, whether it is a read or write. Okay, should I put this length of data to the memory or read from the memory? So write or read operation, what operation has to be done? So all this information must be given by the processor to the device. Okay, now so that is, the processor gives some information to the DMA controller, the starting address, whether it is read or write operation, which has to happen between the memory and the input output device. The starting address, number of words which has to be read, okay, and the direction of transfer, that is whether I want the input to memory is write operation, or memory to IO device. Okay, from memory you are reading to IO device. So it is read operation, whether it is read or write operation which is required. So all this information is sent by the processor to the DMA controller. Okay, so in DMA controller there are some registers to store those informations. Yes, it is also, there is sentence, what happens after the operation is in process, after the DMA transfer, what is the issue, what is the concept, what happens is, once the transfer of data is done, that is processor had given the permission for DMA and that is done, an interrupt or an information is sent to the processor, okay, in the form of signal. Fine. So these are the registers which is used in DMA, which is for storing the information. So starting address is stored in a register. Word count, number of words that can be read or returned to the memory is stored in the word count register. And there is status register. So status register, the interrupt request. So if suppose DMA wants to request for some information, okay, that is, it wants to inform the processor that the operation is complete, okay, it wants to send some signal, interrupt signal to the processor, then IRQ signal is set to 1, okay, and then there is read write. So 1 means it is the read operation which has to happen, and 0 means it is the write operation, memory write operation which has to happen. Once this operation, whatever the task given by the processor is done, read or write operation is done, then the done bit is set to 1. Okay, done bit is set to 1. And also the interrupt enable bit is set to 1, means any more interrupt which by the other devices or by the processor is enabled. Okay, that is IE, and interrupt enable. So these are the different bits in status control. Other than this, there can be the other bits are there which checks whether the data transfer was done properly or there was error, any error during the data transfer. So for all this, for storing the status of data transfer, DMA process, okay, the status and control register is used. So RNW to indicate whether it is a read or write operation. Once the operation is done, the done bit is set to 1. Okay, interrupt request is set to 1 when the DMA controllers wants to send a interrupt to the processor. Okay, IE bit is set to 1, that is interrupt enable is set to 1 after the DMA service. Okay, so that any devices can send interrupts to the device now. Okay, so this is about the different registers in DMA controller. Fine. DMA controller is in interface circuit. Okay, interface circuit, which you have already seen. Interface circuit consists of address decoder, the status register, the data register. Okay, so on those registers DMA, the interface circuit contains, along with it there is DMA controller. Okay, so we'll see, this is a block diagram. In red you can see it is the DMA controllers which is there for few devices. for devices which are slow, like there is no need to take the direct memory access uh, by the keyboard, because we are entering the data slowly, correct? So DMA controller is not required in such devices. Printers, there can be DMA control. Again, it depends on the how the system is designed. Okay, so there is a DMA controller here for the disk, hard disk, and one more DMA controller. So for each device, there can be a DMA controller. These DMA controllers are in interface circuits. Okay, so there is DMA controller here for the network interface card. Before the network interface card, there is DMA controller, so that data can be sent from memory directly to the network. Okay. Similarly, there is DMA controller which controls the transfer between the memory and the uh, disk Fine. Okay. So the three operations which are there. Fine. Now the data transfer has taken place. Okay, there is all the arrangements which are required for data transfer. Usually the data transfer, the memory access is done by the processor. The use of this bus for transferring the data is done by the processor to memory interaction takes place more often. Okay, whenever there is a DMA request, okay, whenever there is the DMA request by the program, only then the access of the memory is accessed by the device. Okay, so this process, the memory access cycle, which was supposed to happen by the processor, is now done by the DMA controller. So there is using of this bus by the DMA controller now, and the DMA controller, we can say, is stealing the bus cycles of processor. Okay, processor, uh, the memory cycles are being stolen by the DMA controller, okay, for DMA operations. And this process is called as the cycle stealing. Okay, DMA controller steals the or uses the memory access cycles of the um, bus from the processor. Okay, and this is called as the cycle stealing. Okay. So that is cycle stealing. Now there are two ways how the DMA control can be given. The processor can give the direct memory access control to the controllers. One is by cycle stealing and the other is block or burst mode. Okay, so in cycle stealing, after each word of transfer, the DMA controller checks whether the CPU needs this particular memory cycle. Okay, and after, when it is not required, when the processor is busy executing some other program and it does not need the memory access, then the DMA process continues. Okay, that is cycle stealing. Whereas in block burst, the block or burst mode, what happens, the transfer is only after the transfer of whole data is done between the memory and the input output devices, control is given back to the processor. Okay, initiate transfer on the bus and exclusive access of memory. The processor, the peripheral devices or the DMA controller does not check whether the processor needs memory access. It completes its work, okay, of transferring the whole large amount of a block of data between the peripheral device and memory, transfers the data to the memory, or the operation takes place, DMA operation takes place, and finally the signal is sent to the processor that the data is transferred and it is complete. Whereas in cycle stealing method, after each transfer of one word of data, the processor checks, the DMA controller checks whether the processor needs the bus control. Okay, so that is the cycle stealing process, and that's about the direct memory access. Thank you.